AB Calculus AB, Unit 9, Day 2, Office Hours. It's page 424, 1, 5, 9, 13, 17, 21, 25, and 425, 29 to 31 all. Almost all odds. One even. Here's the even answer. Pause the video if you need to. Parts A and B. Okay, let's try these problems. So, number 1, it says in each part, use a definite integral to find the area of the region and check your answer using an appropriate formula from geometry. So you're doing these two ways, geometry and algebra. So let's see. I don't know if they give me pictures or not, but definitely going to want to draw a picture. So we have this graph. This function, it's a line. Line is y equals 2 minus x. So we're going to try and find that. So as the area of a triangle, that would be 1/2 base times height. And so that would be 1/2 2 times 2. And so then your answer would be 2. That's using geometry. Otherwise, we could integrate from 0 to 2 of 2 minus x dx. The antiderivative is 2x minus x squared over 2. Definite integral. Plug 2 in, you get 4 minus 2 minus plug 0 in, you get 0 minus 0. The answer comes out to 2. There we go. B. It's a horizontal line. It's through 2. So y equals 2. It's a horizontal line. I'm going from -1 to 1. So using geometry, that is the area of a rectangle, base times height. And the base is 2, and the height is 2, and so the answer is 4. Doing more of a calculus approach, be -1 to 1 of 2. The antiderivative is 2x. -1 to 1. Plug 1 and you get 2 minus -2 gives you 4. C. Okay. Looks like it's 1, 1, 2, 1. This is y equals x plus 1. Up 1 over 1, up 1 over 1, up 1 over 1. So that's the little graph. And it looks like going from 1 to 3. Just trying to find that area. Now, using geometry, I mean, I would use a trapezoid, which we've said is the average of the bases times height. It's just rectangle, base times height. So the bases are 2 and 4. Average of the bases, 2 plus 4 over 2, times the height. This is the height, 2. And so the answer is 6. Or we could integrate it, x plus 1 dx from 1 to 3. Get x squared over 2 plus x from 1 to 3 3, you get 9 halves. It's 3 minus 1 half plus 1. Distribute, you get 8 halves plus 2 is 4 is 6. Same answer. Good to know. All right. So that's geometry and using calculus now. Next one says, find the area under the curve over the stated interval. So these ones, I'm just going to jump right into it. No geometry. Geometry probably wouldn't work very well here. So they're telling you the function, they're telling you the interval, and they're telling you to find the area under the curve. Now, assuming these are above the curve, then the integral should give you the area. So we go 1 to 9. Probably rewrite this as x to the 1/2. So you get x to the 3/2, divide by the new x by multiplied by the reciprocal. 1 to 9. 2/3, 9 to 3/2, minus 2/3, 1 to the 3/2. So this is going to be square root of 9 is 3, cubed of 27, reduces that 9 is going to be 18. That's 2/3. So we could say 17 1/3, or we could, write it 52 thirds. Okay. Okay, number 9. It says evaluate the integrals using part 1 of the fundamental theorem of calculus. So I think we're just going to integrate this. X cubed over 3 minus 4x squared over 2 plus 7x. Don't need to do plus c on definite intervals. You could if you want, but it's going to go away every time. So we're going to plug 0 in. So it's going to be 0 minus 0 plus 0 minus, plug negative 3 in. That's going to be negative 27. That's going to be negative 9 minus, it's going to get squared positive 9. 36 over 2 is 18 minus 21. So this is going to be negative, so negative 48 with another negative, positive 48. All right, 13. The integral 4 to 9 of 2x squared x dx. So what I would do here is I would rewrite this as this is x to 1/2, this is x to the first, rules of exponents. I put the 2 out in front, maybe x to the 3/2 dx. So we're going to get x to the 5/2 divided by the no exponent multiplied by the reciprocal. There's also 2, 4 to 9. So if we plug 9, and this is going to be 4/5, you plug 9 in, 9 to the 5/2 minus 4/5, 4 to the 5/2. Okay, so square root of 9 is 3 to the 5th power. Jeez. 3 to the 3rd is 27, 3 to the 4th is 81, 3 to the 5th is 243. This one is going to be 2 to the 5th power is 32 over 4 is 8 times 4 is, well, those just pretty much canceled, right? But that's supposed to be actually a 5, 4/5. So 2 square root of 4 is 2 to the 5th is 32. All right. we could say it's going to be 4 times 243 minus 32. That'd be 211. So it's going to be 844 over 5. So that could be the answer. Or you could say, well, 5 is 120 times. So that's 168 and 4/5. 168.8. That's fine, too. All right. 17. Negative pi over 4. Positive pi over 4 of cosine x dx. The antiderivative is sine. And so we're going to plug in the top limit. Sine of pi over 4 minus sine of negative pi over 4. Okay. So pi over 4, that's root 2 over 2 minus negative would be quadrant 4. So it's going to be negative root 2 over 2. So it's going to be 2 root 2 over 2 is root 2. All right. 21 is integral of 0 to 1 over root 2 of dx over the square root of 1 minus x squared. So this is inverse tangent. And by the way, 1 over root 2 is root 2 over 2. That might make it a little easier. Root 2 over 2 minus inverse sine of 0. So now this is asking for the angle, principal values. What angle would you plug in to sine to get root 2 over 2? Pi over 4. What angle would you plug in to sine to get 0? 0. The answer is pi over 4. Let's see, 25. 1/4 of 3 over the square root of t minus 5 square root t minus t to the negative 3/2 dt. So I'd rewrite this, and I would say this is 3t to the negative 1/2. That's 5t to the 1/2. That's t to the negative 3/2. I'd do that, and then we use rules of exponents. So it's going to be 3t to the positive 1/2 multiplied by the reciprocal minus 5t to the 3/2 divided by the new exponent multiplied by the reciprocal minus t to the negative 1/2 divided by the new exponent multiplied by the reciprocal 1 to 4. So it's going to be 6 square root 4 minus 10/3 4 to the 3/2 plus 2 over the square root of 4 minus, you can plug 1 in, 6 square root of 1 minus 10/3 1 to the 3/2 plus 2 over the square root of 1. All right, now we just got to simplify this stuff. That's going to be 12. Square root of 4 is 2 to the third power is 8. That's going to be 80/3 plus 1 minus 6 minus 10/3 plus 2. And distribute the subtraction. So let's see, we have 12, 13, minus 6 is 7, minus 2 is 5. And we have negative 70/3. So that's going to be 15, negative 55/3. or negative 67, 18 and 1/3. You really want to write it as a mixed fraction. 2 times 18 is 54. All right. So then on to page 425. Okay. You say use theorem 6.5.5 evaluate the given intervals. Essentially, they're saying break it up. These are absolute value integrals. Break them up. All right. So what we want to do without graphing it is figure out, well, where does it equal 0? So it's going to be 3 halves. And then I would just do a line check real quick. And this is part A, by the way. Line check. Test a value. X equals 2. It's going to be positive, negative. So we've got to break it up in 3 halves, and we've got to fix that part. So it's going to be 0 to 3 halves. Drop the absolute values. You got to put parentheses still, though. Plus 3 halves to 2, 2x minus 3 dx. And so we fix that part by putting a negative in front. Now we just got to do the work. So that's going to be 2x squared over 2 minus 3x. And they're both going to have the same antiderivative. So you got, it's going to be x squared minus 3x. You've got to plug limits in. So it's going to be 9/4 minus 9 halves minus 0 minus 0. And this one's going to be 4 minus 6 minus 9/4 minus 9 halves. So now we just got a little bit of cleaning up to do. Least common denominator. So that's going to be negative 9/4 is going to be positive 9/4 for that chunk. And that's going to be negative 2. And least common denominator is going to be 4. So that's going to be negative 9/4. But it's going to become plus 9/4. And that's negative 8/4. So it's plus 1/4. And we get 10/4. And we get 5 halves. And we get 2.5. 5 halves is fine. So that was A. Part B is 0 to 3 pi over 4 of the absolute value of cosine x. So we can say, okay, when does that equal 0? Well, that's going to be at pi over 2 plus pi k, right? Number line, we just care about from 0 to 3 pi over 4. So I think, that's got to be just pi over 2 is all we care about. Test, I'm going to test 0. 0 in a cosine is positive, negative. So we're going to break it up. 0 to pi over 2 of cosine x plus pi over 2, 3 pi over 4 of cosine x. But that's the negative part, so we got to fix it with an extra negative. That'll force it to become positive. So the antiderivative is sine x. And same antiderivative here. Okay, so we're going to get sine of pi over 2 minus sine of 0 minus sine of 3 pi over 4 minus sine of pi over 2. So sine of pi over 2 is 1, that's 0. That's 1. A sine of 3 pi over 4 is root 2 over 2. So we have a 1 and then another plus 1. So it's 2 minus root 2 over 2. Two minus root 2 over 2. Okay. 30. Let's see if we can fit all these on here. 30a. Now this one is negative 1 to 2 of the square root of 2 plus the square root of x. So this one's a weird because the absolute value is on the inside of the function. And so we have to say, well, x equals 0 is going to be this place. Test the value, x equals 1, positive, negative. So we got to break it up at 0. So we got to do negative 1 to 2. Negative 1 is 0. And in here, the way we fix it is we put the negative in here. That because when x is negative, that absolute value is going to force it to be positive. So we need an extra negative to make the negative positive. So this one's a little different than the others. And 0 to 2, well, 0 to 2, you can just drop the absolute value. It just doesn't even matter. So this one's a little different, but that's our strategy. Now, this is to the 1/2 power. We could do u substitution. U equals 2 minus x. Du equals negative 1 dx. I don't want the negative. So then this is going to be negative square root of u to the 1/2, du. So it's going to be u to the 3/2 divided by the new exponent. So we negative 2/3. 2 minus x to 3/2. Negative 1 to 2. Or sorry, negative 1 to 0. This other one, we could do u substitution also if you want. I don't really think you need it because the derivative of what's inside is just 1, which means nothing's really happening. So, I mean, you could do, okay, well, that's u to the 1/2 to u. That's going to be u to the 3/2 divided by the new exponent. And then rewrite it back in terms of x. So there you go. Now we just got to plug the numbers in. Negative 2/3. If you plug 0 in, you're going to get 2 to the 3/2 minus negative 2/3. Plug 1 in, it's going to be 1 to the 3/2. Plus, plug 2 in here, you get 2/3. 2 to the 3/2 minus 2/3. No, if you plug 2 in, you get 4. You plug 0 in, and you get 2. All right, so what's that all going to be? That's just going to be 2/3, right? This is going to be, so we have negative 2/3 to root 3 over 2, and then we have another negative 2/3. So that's going to be negative 4/3, 2 to the 3/2, right? Negative 4/3. And then this is going to be plus 2/3. The square root of 4 is 2. The third power is 8. That's going to be 16/3. So that's going to be a total of 18/3, which is 6. Unless I messed something up. Looks like I messed something up. Where did we get those values? Here you're supposed to plug negative 1 in. Plug 0 in. You plug negative 1 in, you actually get 3 to the 3/2. So this is actually going to be 2/3, 3 to the 3/2. And then this is just going to be 16/3. So it's going to be plus 16/3. So that's the whole answer. I made a little mistake. Okay, all right. That's part A. Part B was integral 0 to pi over 2, absolute values of 1/2 minus sine x dx. So this is a little more like a traditional absolute value problem. It's all inside of one single absolute value. So you want to figure out when that's equal to 0. So set it equals 0 and solve. Alpha equals pi over 6, quadrants 1 and 2. So x equals pi over 6 plus 2 pi k, and x equals 5 pi over 6 plus 2 pi k. And we're going to do a quick line check between 0 and pi over 2, which would give you pi over 6, just pi over 6. And you can test the value like 0, x equals 0, and that in this would be positive and then negative. So when we rewrite this, we're going to say, okay, let's do 0 to pi over 6, drop the absolute values. That's the positive part, so we don't have to do anything. The next part, pi over 6 to pi over 2, drop the absolute values. This is the part that's going to turn out negative, so we need an extra negative to force it to become positive. The antiderivative is going to be 1/2 x minus plus cosine x. One half x plus cosine x. Plug pi over 6 in, you get pi over 12 plus cosine of pi over 6 is root 3 over 2. Plug 0 in, you get 0. Cosine of 0 is 1. Be careful. And then you got to distribute this negative into everything. So it's going to be pi over 4 plus cosine of pi over 2 is 0. Minus pi over 12, cosine of pi over 6 is root 3 over 2. And we got to distribute this negative. Okay, so we have pi over 12 plus another pi over 12 minus pi over 4. So we have pi over 12 plus pi over 2 is 2 pi over 12 is pi over 6 minus pi over 4. We have root 3 over 2 and another positive root 3 over 2. So that's 2 root 3 over 2's. We have a minus 1 here. And I think we've taken care of everything. So this could be 2 pi over 12 minus 3 pi over 2. So it's negative pi over 12 plus root 3 minus 1. There you go. All right. Last one, 31 part A. Negative 1 to 1, e to the x minus 1, absolute values. So we got to figure out where this equals 0. So it's going to be e to the x equals 1. We're going to take the natural log of both sides. And we get x equals 0. So then we can do a quick little line check. Test. X equals 1. Should be positive, negative. Okay, so we're going to do negative 1 to 1 of e to the x minus 1. Drop the absolute values, put parentheses. And then we're going to do what negative 1 does 0. And then 0 to 1 of e to the x minus 1 dx. Now the negative part is the part we got to fix by adding extra negative in front. So this is going to be negative e to the x minus x, antiderivative, e to the x minus x, antiderivative. If you plug 0 in, e to the 0 minus 0, minus e to the negative 1 minus negative 1, e to the 1 minus 1, e to the 0 minus 0. Now the zeros, they just go away. The e to the zeros are 1s, right? So we have negative 1 plus 1 over e. That's going to be a plus 1, then a minus 1, and then that's going to be plus 1. Plus e to the first, that's a minus 1, that's a minus 1, that's a minus 2. So it's going to be I don't know, whatever order you want to do. 1 over e plus e minus 2. All right, 1 to 4 of the absolute value of 2 minus x over x. So this isn't around the whole function. If it's around the whole function, I feel like it's a little more straightforward. But we do want to figure out where to break this guy up. And so we set it equals 0. Yeah, x equals 2. You can do a line check. Test the value. X equals 3. It's going to be negative, positive. So we got to break it up at 2. So we're going to do 1 to 2. Drop the absolute values. And we're going to do 2 to 4. Drop the absolute values. Now the one that has that's going to be negative is the one we've got to fix. 2 to 4, this one's going to be negative. So we need an extra negative. Now integrating this is actually 2 over x minus 1. So this is 2 natural log of the absolute value of x minus x. That's the antiderivative for both of these. 2 natural log of x. Absolute value of x minus x. 2 to 4. Okay. So now we just got to calculate these. So 2 natural log of, put 2 in there, minus 2 natural log of 1 minus 1. Natural log of 1 is 0. Minus 2 natural log of 4 minus 4 minus 2 natural log of 2 minus 2. And we got to distribute this, but then we got to distribute that also. So we got 2 natural log of 2 minus 2 plus 1. And we got minus 2 natural log of 4 plus 4 plus 2 natural log of 2 minus 2. So try and clean this up. 2 natural log of 2. So we actually have 4 natural log of 2 minus 2 natural log of 4. That's a negative 1. Negative 1. Positive 3 minus 2 is plus 1. Now, if you use the rule of that power rule for logs, you bring these in. 2 to the 4th is 16. 4 to the 2nd is 16. These are actually the same as each other. They cancel each other out. Your final answer is just positive 1. So it worked out really nice. That's it. You gotta know how to deal with absolute values now.